When traffic is affected by construction, maintenance, or utility operations, traffic control is needed to safely guide and protect motorists, pedestrians, and workers in and through work zones. This zone is the area between the first advance warning sign and the point beyond the work where traffic is no longer affected. Most temporary traffic control zones can be divided into 4 areas. In this part of the training, we'll look at each of the areas and examine them for one direction of travel. If the work you'll be doing affects more than one direction of travel, the same principles we cover here will apply to traffic in all directions. These are the 4 areas of temporary traffic control zones we'll be discussing. Accidents can occur in all of these areas if they are not properly controlled. Advance warning area, transition area, activity area, and termination area. The advance warning area prepares drivers and alerts them to what's coming. An advance warning area is necessary for all traffic control zones because drivers need to know what to expect. Before reaching the work area, drivers should have enough time to adjust their driving patterns. In the advance warning area, traffic control devices may vary from a series of signs starting a mile in advance of the work area to a single sign or flashing lights on a vehicle. The advance warning area, from the first sign to the start of the transition area, should be long enough to give the motorist enough time to respond to the control devices. For most operations, the length can be 1 mile for freeways or expressways, 1,500 feet for most other roadways or open highway conditions, or 1 block or more for urban streets. Next is the transition area. When work is performed within 1 or more traveled lanes, a lane closure is generally required. In the transition area, traffic is channeled from the normal highway lanes to a new path, which is required to move traffic around the activity area. Most often, this is accomplished with tapers to close the lanes. The transition area should be obvious to drivers. The correct path should be clearly marked with channelizing devices so that drivers will not make a mistake and follow the old path. If the existing pavement markings create confusion, interim markings should be used. A taper is a series of channelizing devices placed at an angle to move traffic out of its normal path. There are 5 general types of tapers used in traffic control zones. Merging tapers close a lane of moving traffic on multi-lane highways where a merge is required. The spacing for channelizing devices should not be greater than the speed limit. Lane shift tapers move traffic to a different lane where a merge is not required. Shoulder closure tapers are needed to close shoulder areas. Two-way tapers control two-way traffic, where drivers are required to alternately use a single lane. These tapers are used when flaggers are present. Downstream tapers are those installed to allow traffic back into the normal path. The length of each type of taper is very important and is determined by several factors. Let's look at each of these factors in more detail. The length of a merging taper which is used to close a lane is determined by the speed of traffic and the width of the lane to be closed. The 2 formulas for determining the length of tapers for lane closures are discussed in the Manual on Uniform Traffic Control Devices. For speeds of 45 miles per hour or greater, the merging taper length should be at least the width of the lane multiplied by the posted speed or the observed operating speed. For speeds of 40 miles per hour or less, the length of the taper should be at least the product of the width of the lane times the posted speed divided by 60. This is actually the high-speed taper multiplied by the factor of the posted speed divided by 60. In most tables, the equation is shown like this. Most state and local manuals include tables showing the required taper lengths for various speeds and lane widths. For example, a 40-mile-per-hour posted speed and an 11-foot lane requires a 295-foot merging taper. The lane shift taper is used when traffic is only being shifted and no merge is required. Therefore, the taper does not have to be as long as a merging taper. The minimum taper length is 1/2 L, where L is the computed length of a merging taper for the given posted speed and width of the lane shift. When an improved shoulder having a width of 8 feet or more is closed on a high-speed roadway, it should be treated as a closed part of the roadway. This is because drivers expect to be able to use the shoulder in the event of an emergency. The shoulder taper should be 1/3 L, where L is the shoulder width multiplied by the posted speed. If the shoulder is used as a travel lane, however, the taper is equal to L. The two-way traffic taper is used in advance of a work area that occupies part of a two-way road when the remainder of the road is used alternately by traffic in either direction. A short taper is used to slow down traffic by giving the appearance of restricted alignment. One or more flaggers or temporary traffic signals are used to assign the right-of-way in such conditions. Two-way traffic tapers should be a maximum of 100 feet long, with channelizing devices spaced at a maximum of 20 feet to provide clear delineation of the taper. A downstream taper is used at the downstream end of the work to allow drivers back into the lane that was closed. It's placed in the termination area. While closing tapers are optional, they may be useful in smoothing traffic flow. However, they may not be advisable when material trucks move into the work area by backing up from the downstream end. If a closing taper is used, it should be at least 100 feet in length per lane. Here is a table from the Manual on Uniform Traffic Control Devices that shows the lengths for the 5 types of tapers. Let's briefly review tapers and taper lengths. Where traffic on a multi-lane highway must merge, the required length is the function of the speed limit and the lane width. If traffic on a multi-lane road is to be shifted to a different lane, the taper is 1/2 the length of the merging taper length. When working on an improved shoulder, the required taper length is 1/3 of the merging taper length. Now, when traffic is on a two-way road and it's reduced to one lane, a taper with a maximum length of 100 feet is needed. And to let the driver know that he may return to the closed portion of the roadway, a 100-foot taper may be used. If restricted sight distance is a problem, for example, a sharp vertical or horizontal curve, the taper should be moved well in advance of the obstructed view. Beginnings of tapers should never be hidden behind curves. Traffic should be observed to see if the taper is working correctly. Frequent use of brakes and evidence of skid markings are indications that either the taper is too short or the advance warning is inadequate. The activity area consists of 4 distinct spaces. They are the longitudinal and lateral buffer spaces, the work space, and the traffic space. Buffer spaces are open and unoccupied spaces and provide a margin of safety for traffic and workers. Although they are optional, they should be provided whenever field conditions permit their use. The longitudinal buffer space is between the transition area and the workspace and provides room for the driver to stop his vehicle if he fails to negotiate the transition taper and before he enters the actual workspace. It is important for the buffer space to be free of equipment, workers, materials, and vehicles. The length of the longitudinal buffer space is based on the stopping distance for the speed being considered. Table 6-1 of the Manual on Uniform Traffic Control Devices provides guidelines for the length of buffer spaces for various speeds. It is measured from the end of the transition area to the beginning of the workspace. Situations occur where one lane of traffic uses a lane that normally flows in the opposite direction. In these situations, a longitudinal buffer space should be used to separate the two tapers for the opposing directions of traffic to help prevent head-on collisions. Lateral buffer spaces separate moving traffic from the workspace as well as opposing streams of traffic. The width of this space is determined by engineering judgment and is often governed by the portion of the roadway which is needed to perform the actual work. The workspace is that portion of the roadway which contains the work activity. It is closed to traffic and set aside for exclusive use by workers, equipment, and the storage of construction materials. Workspaces may remain in fixed locations or may move as work progresses. For long-term operations, the workspace may be shielded by barriers to exclude traffic and pedestrians. The traffic space is the portion of the roadway in which traffic is routed through the activity area. Channelizing devices are used to separate the traffic space from the work activity at a spacing no greater than twice the posted speed limit. Every feasible effort should be made to minimize traffic conflicts with the work area. These are suggestions. Use traffic control devices to make the travel path clearly visible to drivers. For nighttime operations, the traffic control devices must be retroreflectorized and have a large surface area. Place channelizing devices between the work area and the traveled way. Provide safe entrances and exits for work vehicles. Flags and flashing lights should be considered on work vehicles exposed to traffic, and a truck-mounted attenuator be provided whenever possible to protect work crews. The termination area provides a short distance for traffic to clear the activity area and return to the normal traffic lanes. It extends from the downstream end of the activity area to the End Roadwork sign. A downstream taper may be placed in the termination area. For some work operations, such as a single location utility or maintenance repair, it may not be necessary to display an End Roadwork sign because it will be obvious to drivers that they have passed the activity area. Avoid gaps in the traffic control at work zones that may falsely indicate to drivers that they have passed the activity area. For example, if the work includes intermittent activity throughout a 1-mile section, drivers should be reminded periodically that they are still in the work zone. The primary purpose of the guide sign, Roadwork Next Miles, is to inform the driver of the length of the work zone. It should not be erected until work begins. In mobile operations, the advance warning area may be provided by signs and flashing lights on the work vehicle. Additional advanced warning signs may be warranted depending on the volume and speed of the traffic. A shadow vehicle equipped with an arrow display and flashing lights may also be used. With mobile operations, the transition area actually moves with the activity area, and the buffer space is the area between the shadow vehicle, if one is used, and the work crew. The termination area is usually obvious to the driver passing the work vehicle. The use of a truck-mounted attenuator should be considered for mobile operations. As a review, these are the 4 parts of a traffic control zone. The advance warning area alerts the driver that there's something ahead that demands his close attention. In the transition area, traffic is shifted or moved to eliminate interference with work activities. The length of the taper should be computed or obtained from a table. The activity area set aside for the actual work to be performed, to provide for the movement of through traffic, and to offer a margin of safety for both workers and motorists. And the termination area tells the motorists that they are out of the construction area and may resume normal driving. This concludes the review of the 4 basic parts of a temporary traffic control zone and their function. In the next session of the series, we'll be reviewing some typical applications that you'll be using in your work.